We're going to continue our discussion of function properties and look at increasing, decreasing constant behavior next. So to begin that, imagine you have this graph that's being shown on the screen here, and you want to be able to describe it to another person. How would you explain it? And again, imagine that they can't see this image, but you're kind of describing it to them. How would you do that? Pause the video and see if you can take a shot at explaining it. Okay, well, you may have said, it passes through the origin, it passes through -1, -1, and you might do that sort of approach, or you might say, as you go from right to left, it is going down, and then it goes up, and then goes down, and then goes up again. That sort of description is really talking about increasing and decreasing behavior. Now, to formalize, to discuss increasing, decreasing, and constant behavior mathematically, we need to do a little bit of technical definition, and then we're going to do it more informally. So increasing says f of x1, or f of x1 is less than f of x2 for all x1 less than x2. Now, informally, what that means is that, okay, so imagine here's your graph, and you have a function like this, and so you might have x1 here, you might have x2 there, and then you look at their associated y values, which we would call f of x1, and then this one would be f of x2. Okay, and so we can see here that when we look at the y values associated to the x's, the f of x2 is bigger than f of x1. And so that fits our definition of increasing. Now, informally, this is the idea here is saying as you progress to the right, you are rising vertically. That's all. Another way students sometimes like to think of it is, on this region you have quote-unquote positive slope, but again, slope is associated with linear functions, and we don't always have a linear function, but sometimes it helps students to think, oh, where's the slope positive? Okay. Decreasing, similar idea, but now f of x1 would be greater than f of x2 for all values on that interval. Okay, and I do want to stress it is open interval, so when you are asked for increasing and decreasing regions, always use parentheses on both ends, regardless if you have the point or not, because we don't talk about a point as increasing or decreasing. I digress. Okay, so now here our function changes a little bit. We have something like this. Let me do a little bit better job there. Okay, and so again, we have x1, x2, and now we look at their associated y values. So we have f of x1, and here we have f of x2, and we can see from the diagram that the y value for x1 is greater than the y value for x2. So then that is going to, so that fits our definition. Now again, informally, as you progress from left to right, the function falls vertically. That's the idea of decreasing. Okay, and constant behavior, well, that one's a little bit easier to describe. That just says the y values are the same for any x values on that interval. So this one might come a little bit more easily to us, but we would just see something that's flat, and so as we look at x1 and x2, we can see that their associated y values, f of x1 and f of x2, are the same. Okay, so then this one would be more like as you progress from left to right, there's no change. Okay, so then just to kind of wrap this one up, we want to maybe determine the intervals of increase, decrease, and constant behavior. So before I go through this, I want you to try it on your own. So see if you can identify, well, let's do increase first. So I'm just going to say here's the increasing intervals, here are the decreasing intervals, and here are going to be the constant intervals. So again, take a shot at these and resume the video when you're ready. Okay, and so increasing, we might identify that as kind of this chunk, right? As we go from left to right, we're rising vertically, and this chunk. Okay, so I would say it's increasing on, and again, we always use parentheses, and we don't use brackets, but then we're talking about these as intervals, right? So these are intervals, okay? And when we communicate these, we're talking about the x interval, so we're looking at the x values corresponding to where it is increasing. And I know that's a little bit of a sticking point for some students, but that's just kind of convention here. So then we would also say it's increasing from when x is equal to 1 until infinity. It would just continue increasing. Okay, decreasing, you might see, okay, as you go from right to left here, right, so as you go from right to left, it is falling vertically in that region and also in this region. So my answer for decreasing would be, again, all the way from negative infinity to negative 1. Again, these are x values. And then, again, it would decrease from when x is 0 to when x is 1. Okay? And this one, for constant behavior, are there any places where it's flat, where it doesn't change vertically? Nope. So I'm going to say none. And that's going to be an intro video to increasing, decreasing, constant behavior of a function.